Okay, hello everyone. Welcome again to this 3-week session on OT and the cybersecurity. Adam, can you help me to take in these all in the lobbies? Yeah.
I'll do that. Don't worry about that.
Okay. Yeah. Okay. So yeah. So already we finished the 2 sessions on operational technology and the cybersecurity, and this is the 3rd session of this series, and definitely we will start the session by discussing the intrusion detection systems, and especially we are working with some rules for the SNOT, and I think we already installed the SNOT and used in our last session. So today we are just creating some new rules, and I will show you how you can manage the predefined and the local rules in SNOT intrusion detection system. So we will discuss the complete rules formats as well, and we will check their usage for the OT networks. And in addition, we will install the honeypot today, and we will apply the different security methods by using that honeypot to protect the systems from attackers and the security vulnerabilities. So let's start the session. Okay, and the session 1 and the session 2 recordings are available. And I added some other labs as well, where you can learn how you will make your own setup by using the Kali and the Ubuntu machine. And some important settings are there. I added the video for that as well, okay, where you can work with the screen resolution, where you can make your own network, okay, and then both operating systems, they will communicate easily with each other. So, and how you can create your VirtualBox image for reusing that, okay. For example, if the one time you install all the things, and if there is any problem with any operating system, that will be crash or anything happened with that, so you can reuse that image, okay, the virtual machine image, which is also you can create easily. I will guide you today as well, okay, a little bit quickly about all this stuff, okay. Anyway, so yeah, again, this is my introduction. Already you knows me, and this is the 3rd session, okay. So this is my brief introduction. I'm working as a associate professor in University of Limerick, and my field is cybersecurity and wireless communication as well, okay. So these are my small profile in front of you. Okay, so I'm starting, okay, with this slide, okay, properly. So yeah, I'm starting my discussion with the SNOT usage and its rules. Already you know that SNOT is intrusion detection system, and that can perform the real-time traffic analysis and packet logging on IP networks, okay. So let me explain the few things first, okay. Quickly, I will finish these almost around the 10 slides we have, okay. I will finish these 10 slides, and then after that, okay, we will start our practical things and the hands-on things. So as we discussed in our last session, that SNOT is a powerful open source network intrusion detection system that can perform the real-time traffic analysis and packet logging on the IP networks. So, but before SNOT tool deployment, it is very important to understand how to write and manage the rules, and as well as the differences between the individual rules and the local rules files, okay, which these SNOT intrusion detection systems contains. So these rules can be categorized into 2 main categories, okay. The one is local, and the other one is the predefined rules, and each serving definitely they have their different purpose, okay, within the system, within the SNOT system. Okay, so for example, the local SNOT rules basically are custom rules, okay, and the users and the administrators, they can create and organize, okay, those rules. And definitely it's depend on the organization need specific need or the scenario as well. So local rules basically written by the administrator, okay, in any organization to meet the specific requirement of their network, of their OT networks, of their IT networks, and they can adjust or update these rules quickly in response to the new threats or the changes in the network, okay. Whereas the predefined rules, basically the SNOT rules are those that come from the SNOT community or from the official SNOT rules providers, okay. These rules are developed and maintained by security experts and are designed to detect a wide range of common threats, and these are basically the predefined rules, okay, which we have. And here you can see this is the component of a SNOT rule where we have the different components like action, protocol, source address, source IP address, source port address, direction operator, okay, destination IP address, destination port, and the rule option. For example, the first action, this basically part is defining and specifying that what to do when the rule matches, okay, like for example alert, log, activate, dynamic, drop, reject, okay, these types of things you can perform in this area in the action, okay. You can change the action, okay, like for example in this rule the action is alert, okay, and we can also add the reject, and it's totally depend on your requirement and your needs. And then the second part is the protocol, okay, and which is basically specifying the protocol, okay, to check and to check which common protocols are available, like TCP, like UDP, like ICMP, okay, that is the Internet Control Message Protocol. We are using that for to check the connectivity and the IP as well, okay. So in this case the TCP is there. So this is basically showing the protocol, okay, which we want to check. And then there's the source IP address, okay, and this section is basically showing the source IP address or the network, okay, and as any IP address, okay, as any IP address, okay, and the source port, okay, this will basically showing the source port, and we can use any for any port, okay, any term we can use for any port. Whereas for the ICMP protocol, okay, usually we are using the any word for that, okay. And the directional operator is there, okay. This is the directional operator. If I will little bit show to you, yeah, this is the directional operator, okay, and basically it is showing the direction of the traffic, okay. And this is the common operator, okay, like the unidirectional. It is showing that this is the traffic is going from the source to destination, like that, okay. And then there is a destination IP address is there, okay, and we can also specify the destination IP address here, okay, or the network address, okay, we can add here. And we are also using any for any IP address, okay. So you can also specify and you can also write, okay, the specific IP address here as well. The destination port mean it will specify the destination port, and we can use any for any port, okay. And especially for the ICMP packets, this is just example, and we are using the any word for that, okay. And we can also add any destination port number here as well, okay. And then we have the message, okay, the rule options, okay. In the rule options you can see these are the conditions and the actions, okay, to take if the rule match with any with the any parentheses, and these are the separated by the semicolon. So these are the common options where we can add the message, okay. Basically in this case our message is the TCP packet detected, okay. So we are using these common options here, like message, like content, like flags, like thresholds. Okay, so let me explain you more in detail, okay, in the next slide, okay, and where you can understand basically the main purpose of these all the sections. Okay, before going to the next thing, okay, what we are doing, first of all, I'm making, okay, a rule, okay, that is internet control message protocol rule I'm making, okay, for this node. Okay, and ICMP basically is the internet control message protocol, and this is one of the, you can say, the fundamental protocol which we are using within the IP networks. And this protocol basically we are using to for the diagnostic purpose and for the control purpose as well. Okay, and this protocol is also very useful for the monitoring and for the managing the traffic. Okay, and because ICMP traffic is important, okay, important for for diagnostic and for the control purposes as well. Okay, so this is specially designed to monitor and manage traffic, okay, within a network, and commonly used for network diagnostic. And whereas the trace route, okay, the trace route is another, we can say, the function which we are using, okay, especially to trace the path, okay, packets take to reach the destination, and it will help to identifying the routing issues and understanding the network topology as well. Okay, and by monitoring ICMP traffic, okay, so the network administrator can diagnose connectivity problems and ensure the network is functioning correctly, properly or not. Okay, and whereas the ICMP is also used for malicious purposes as well. Okay, and to manage all the traffic and to protect the network, okay, from the network reconnaissance, okay, where the attackers use the pings packet, the echo request packet, okay, to discover active host and map out the network as well. Then ICMP time exceeded messages can be used, okay, in the trace route, okay, to for gathering the information about the network structure and the devices as well. Okay, and one of the well-known attack is the denial of service attack. Okay, and this is initiated by using the ICMP flood attackers, where the ICMP flood attackers send a large number of echo requests, okay, and to the target, and then the services will not available or maybe busy. Okay, and then there is a ping of death attack, okay, where the attackers, they are sending the ICMP packets, okay, to crash, okay, to crash the target system as well. Okay, so that's why ICMP protocol is very important, okay, and we are using for these all the purposes. Yeah, covert communication mean where the attacker may use the ICMP packets, okay, to tunnel other protocols and bypass the firewall rules. Okay, and they are also using the detection mechanisms. Okay, so ICMP tunneling can be used for communication channels as well, okay, within the compromised network. So that's why this protocol is very important. So that's why we are making the first rule for ICMP, okay, by using the ICMP. This is easy for you to understand, okay, how these rules are working basically. And let me go to the next slide. Okay, yeah, this is the basically, okay, rule which we are working, okay, in today's labs. Okay, so we will make a simple ICMP rule, and this not rule basically generates an alert, okay, for any ICMP packet detected on the network, okay, with the destination IP address. Okay, for example, we are using the destination IP address, so the alert is triggered, okay, to notify that an ICMP packet has been found, okay, with a unique identifier. Okay, we are using the unique identifier, the number. Okay, so let me explain the rule, okay, and its different components. For example, here you can see we have the alert, okay, and this alert is a function, okay, and we are generating an alert by using this component here, okay, and when the rule match, and this action instructs not to create an alert, okay, if the specified conditions in the rule are met, okay. So this is the alert, okay. The first component of this rule is alert. And then we have the ICMP, because it will apply the rules, okay, to ICMP packets and specify that the rule is concerned, okay, with ICMP traffic, okay, and such as ping request and the replies, okay. So we need to identify and we need to add the protocol here, okay. So this is the protocol section. And then the any and any, so we will just specify that source IP address here and the source port here, okay, and can be any IP address. And this part of the rule basically indicates that the source IP can be any IP address, okay, and making this with any, okay, rule, and this is the broadly applicable, okay. It will detect any type of traffic which is coming from any system, okay. And then this one, okay, this is the directional, basically the traffic direction flow. It is showing the traffic direction flow, that it will show the traffic direction is from the source to the destination. And it will also indicate that the rule applies to traffic moving from the source IP address to the destination IP address, okay. And then we have the destination IP address. You can specify the destination address here, or you can just use the simple any, okay, terms here, okay. So, but in my case, because I have environment in the virtual machine, so I added, okay, the one destination target IP address here, okay. And then in the last, okay, here I use any again. It will show the destination port basically, okay, and that can be any. Okay. And because we are using the ICMP rule, so as we discussed in the previous slide, and mostly for the ICMP rules, we are using the any terms, okay, especially for the port numbers, okay. And then we have the rule options here, the last section, okay, here. These are the rules options, okay, this part, okay, and the last part of this rule, okay. And here we can just writing our message, okay, that ICMP packet found. You can write any message here. It's totally up to the administrator, up to the security expert, okay. So you can add any message here, okay. And yeah, this message, log this message when the rule match, okay, and it will provide a descriptive message for the alert, okay, and especially it will helpful to identify the nature of the alert in the logs as well. And then in the last we have the SID, that is a unique identifier for this rule, okay. And basically the snot ID and the SID, okay, SID is the snot ID, okay, short form of the snot ID, is a unique identifier which we are using as a reference and to manage the rule, okay. And this signature ID uniquely identifies, okay, snot rule, and it is important to ensure that each SID is a unique, okay, within the snot rule, okay, to avoid any conflicts and ensure the proper rule management mechanism, okay. So this is all about the rule, and we are using this rule as well, okay, in today's lab. And let me explain these all the things, and then one by one, okay, we are using, okay, and implementing and deploying these rules, okay, in our virtual environment, okay. Okay, yeah, this is the second rule, okay, which we are creating in today's hands-on section, okay. And this basically this rule, okay, we are also working with ICMP packets, and in this rules we are blocking, okay, and logs any ICMP packet, like for example the ping packets, okay, which are coming from the specific IP address, okay. and we are setting the alert message here, okay, that reject ping from, okay, .5 machine. Okay, so we are just adding the last digit of that machine IP address, that is a 5. Okay, so and the rest of the things are already explained to you in the previous slides. Okay, and the reject action is basically we are using to block the packet and send a rejection message. Okay, and I will show you practically, okay, how this tool rule is working. Okay, and basically this rule stop the traffic, okay, and inform the sender that the traffic was rejected as well. Okay, and then in this rule, okay, there is another thing that is a revision 005. Okay, in the last part you can see here, in the last part, this is a revision. Okay, and basically in the snort rules, okay, we are adding this in the last. Okay, it will showing that this is the 5th revision of this rule. Okay, and it will help us, okay, to revise the rules. Okay, which version is this? Okay, and especially for the rule management purposes, okay, it will ensuring that the most current and the accurate version of the rule is in use. Okay, so that's why we are adding this in the last. Okay, so this is the 5th revision, for example. If your rule is new, so no need to add this one in the last. Okay, so it's totally up to you. I'm just showing, explaining this thing to you here, okay, as a reference. Okay, so yeah, these two rules we are using first of all. Okay, and then after this, okay, we are using another very good tool, okay, that is a pen box, okay, honeypot. Okay, and this is one of the offensive security testing toolkit. Okay, so we're downloading and installing, okay, in Ubuntu machine, this one, and then we will check, okay, its impact. Okay, and it is the offensive security testing toolkit, and basically Pentbox is a toolkit, okay, which is designed to identifying any vulnerabilities, okay, and any exploitation, okay, related to the security. Okay, and because this toolkit has many tools, okay, and it contains the many techniques, okay, and which we will use, okay, to simulate the attacks and check the effectiveness of the defenses as well. Okay, and the key capabilities of this tool are vulnerability identification, because this tool is scanning the system and detect the weaknesses in configuration, in applications, or in the networks as well. So once the vulnerabilities are identified in this pen box, okay, and this tool will exploit them and demonstrate the potential impacts and the risks as well. And it is also useful for conducting any comprehensive penetration tests, okay, and it will evaluating the security postures of the systems and networks and the applications as well. Okay, so we are installing this one. So as per the integration with the honeypot, the Pentbox toolkit, okay, it is integrated with the honeypot as well, okay, to enhance the security testing capabilities as well. And it simulates the attacks, okay, against the real or simulated environment, and that basically incorporates the honeypots. Okay, and this tool is also creating the scenarios, okay, for the penetration test that involves to interact with the honeypots, okay, to test the detection and response capabilities as well. Okay, and this is also providing realistic scenarios, okay, especially for the penetration test, and by using the honeypots as well. So it has the different categories, okay, it has the cryptography tools, network tools, the web reconnaissance tools, IP gathering tool, okay, and the different types of tools it contains. Okay, so we are using the honeypot today, and I will show you how this tool is working basically in real scenario. Okay, so what are the benefit of this tool? This is very user friendly tool, okay, and you can easily download and install this tool and use on your machine, okay, especially in the OT environment. So we are using the pant box, okay, with honey pots, okay, and which will provide the complete security assessment things, okay. So this is just one example, okay, for your learning, although we have more smart honeypots, okay, available. Existing honeypots are available, which are more advanced features. They have more advanced features. So okay, so we are using this one as well. Okay, so basically we are using the pant box, okay, and with these 3 ports functionalities, okay. And like for example, first of all, we will use this pant box for the port 22. 22, yeah, this is used for the secure shell protocol, okay, and SSH is one of the secure network protocol that provides the encrypted communication sessions, okay, over a network connections. And the SSH is also encrypts the data during the transmission and providing the integrity of the data as well. And SSH also supports the authentication methods, like including the password, public key cryptography, and the two-factor authentication as well. So this is widely used protocol, okay, especially to secure your remote access and the command execution and the file transfers things as well, okay. And then we have the port 23, okay, which we are using, and this is commonly used with the telnet protocol, and this is one of the old protocol, okay. And the telnet is a network protocol used to provide interactive command line access to remote systems. And because this is the old protocol, and so it has a very security concerns as well, okay, because this is transmitting the data without encryption. Okay, it is sending all the details of the password and the username in the plain text, so which is one of the vulnerability of this protocol. And so we are using the SSH, okay, as compared to the telnet. This is the replacement, we can say, due to the better security features. And then in the last, we are using the port 80 HTTP, okay, and this is the hypertext transfer protocol, and this is one of the foundation of the for the data communication. And this is used in the web browser, okay, to retrieve the web pages, okay, especially working with the web traffic, okay. So we are using this one as well, and this is also transmitting the data in the plain text, whereas we have the HTTPS as well, that is a secure, okay, which is using the SSL and the TLS encryption methods, and that is the port number of that is 443, okay, and the simple AT is for the HTTP. So we are using, okay, these 3 ports in this honeypot, okay, with the pent box lab, in the pent box lab here. So this is our lab scenario, okay, the same scenario we are using, okay, which we used in session 1 and session 2, and where we have the Ubuntu machine, okay. It contains the latest Ubuntu operating system, okay, and Snort is already there, okay, we already installed the Snort, okay, and today we are installing the Pentbox honeypot, okay, that is a 1.8 version. And then on the other side we have the Kali Linux, okay, where we will perform the different attacks from the Kali Linux, okay, and we are using the telnet and SSH protocols and the ping commands as well, okay, to check all the processes and between these 2 machines and the target and the attacker machine. So yeah, these are okay, the information, okay, and which we are using, especially with the rules and with the honeypot. So now I think this is the time, okay, we can implement and we can try all the rules, okay, by using the lab scenario. Able to you? Adam, the screen is visible?
Yeah, all good.
Okay, all good. So here we have the one Kali Linux. Okay, this is the latest operating systems, and then we have the Ubuntu as well. Okay, the two operating systems we have here. And what we did here, okay, we just created our own network here. You can just go to the tools, and these are the tools. Okay, if you will open the network manager, so here you can see, okay, this is, you can create your own network here, and then you can change the IP address of this network card from here. Okay, otherwise when you are installing the both operating systems in your virtual environment, so by default, okay, the IP address will be the same. Okay, and they will not able to communicate with each other. Okay, so it is you can just open this area and you can set your own network. Okay, and after creating by using this button, you can create a new network, and you can just add your own name of the network, and you can also use your own IP address here. Okay, and then after that, one by one, you can just open the settings of these operating systems, and then you can go to the network section, and from here you can select the network. Okay, and then automatically, okay, your created network will be appear here, so you can select from here. Okay, and then you can try to ping, okay, both systems, and then you can check, okay, they are communicating with each other or not. Okay, so this is the one of the setting. Whereas for the screen resolution setting, okay, already I created the video for you. You can watch that, and you can set the screen resolution for these new version of the Ubuntu and the Kali. Okay, because the simple method, the CD image is not working, okay, with these new versions. So you need to run some commands, okay, for this. Yeah, so let me open. Yeah, this is the Ubuntu machine, so I need to just simply add the password here. Okay. Yeah, you can just, and this is the Kali Linux. Okay. Okay, so first of all, I'm just starting the snot tool, okay, in Ubuntu, and then after that I will generate a ping request from the Kali machine, okay, and then we will check the impact, okay, what will be the impact on our snot and Ubuntu machine, okay, and after that we will deploying and creating a new rule, okay, and then you can see the difference. Okay, so first of all, I need to change the directories. Okay, and by default the snot is here, and we will, yeah, go to the rules here. Okay, and then after this I'm just starting simply the snot. Yeah, okay, so this command we are using, okay, to start the snot intrusion detection system, and the sudo snot is basically running the snot. Okay, and then whereas a console, this will specify the alert mode, okay, and directing the snot to output alerts, okay, to the console, and the Q we are using okay, to reducing the amount of informational messages, okay, which are printed to the console, and whereas the U is running the snot under the user snot for the security purposes as well, and the G is showing that run snot under the group, okay, for the security purpose. And then in the last we can specify the configuration file directories, okay, which will contain all the rules and the settings of the snot. And then in the last we can specify the network interface card address. In my case, my interface card is ENP. I think the screen is not fully visible to you. I need to, okay, yeah. And then in the last, yeah, this is my network card address, okay. So maybe it will be different on your side, okay. So you need to add the network address in the last here. Okay, so you can just simply press enter. It needs your password again. Okay, so now the snot is working here, okay. So simply you can just move to the other machine here, and you can just generate a ping from here, and that can add the IP address of that machine, and you can send the ping messages. And you can see the impact here, okay. Nothing is coming, okay, on your snot because there is no rule set yet, okay. So we need to create and set the rule first, okay, and then we will check the impact, okay, here in the snot in the IDS, okay, as well. So let me stop this, okay, and I need to stop the Kali as well. Yeah, like this, okay. Again, I'm coming to the Ubuntu machine here, okay, and this time I'm just checking all the directories and all the rules, okay, which this file contains. And you can see we have a lot of rules here, okay, and from the attack response rules, okay, DNS rules, okay, DDoS rules, okay, and so many SNMP, FTP, web, local, okay, a lot of rules are available. So basically these rules are, as I explained in the slides, these are categorized, okay, into two main categories: the local rules and the predefined or the standard rules, we can say, okay. So we have the local rule file here. You can see this is the local rules in the snot, okay, and these are the custom rules. Basically these are the custom rule files where you can place your specific rule. So these files allow you to maintain a clear, okay, distinction between the standard rules and the custom rules. So, and then the other rules we have here, those are the standard rules, okay, which are available here. Okay, the standard rules, it will predefined rules and maintained by the snot developers or the rule vendors, okay, and these rules are regularly updated, okay, with the new detection capabilities as well, okay. So these intrusion detection systems are working with these rules. If these rules are updated, so definitely their performance is better, and they will catch the new security vulnerabilities as well, okay. And whereas the local rule file, which will contain the custom rules, you can write your rules there as well. So I'm using the both files today, so, okay, the both files I'm using. First of all, I will do some changing in the ICMP rule file, which is a standard rule file here, okay, and then I will do and make the new rule for the local rules as well, okay. So first of all, okay, I'm making the new rule for the ICMP rules, okay, file. I will store that new rule in this file, okay. So simply you can use the gedit tool, okay, which is available in your Ubuntu. So you can simply use that and to edit this icmp.rules file, okay. Simply you can type and ICMP, yeah, this is the file name, okay, which you need to use, yeah. And yeah, this is the file, okay, in front of you. So it already has so many things, so many rules are defined, okay, which are available here. So our main rules are started from line 28, from 29, okay, and we are adding the new rule in line 28, okay, here, okay. So, and then we will check, okay, the impact of this rule, okay. And I'm using the same rule which I explained to you in the slides in the presentation, okay. So alert and ICMP, and then you can define any, and you can set the direction, and you can add the source IP, and the port should be any, okay, and you can add the message, inside in this commas, okay, you can use the message. For example, I'm adding ICMP, okay, packet found, and then you can use the semicolon here, and in the last you can add the ID, okay, you can add any ID. In my case, I'm adding this one, and you can close with the semicolon as well, okay. So this is the rule, okay, which I created and already explained to you in the slide, okay. So let me check again, okay, alert, yeah, ICMP, any, then the direction is there, IP is there, any, and then the message is there, message is ICMP packet found, and then this is the, okay, specific and unique ID, okay. Then I need to close this. Yeah, you can just simply save, okay, this file, save, and you can close this, okay. So now I created, okay, the new rule, okay, in this file, and simply now you can run your snort again, okay, by using the same command, and you can just run and go to the other machine, and you can again generate, okay, the attack and the pinging, okay, and then you can see the impact here, see, and it will showing the target, okay, the attacker machine ID as well, okay, and all the details with time and with date and all the stuff, okay, is here, okay. So this is the impact of this rule, okay, which we created. So you can just close this from here, and you can also stop that pinging by using the Control Z, okay. And then, okay, this is the first thing, okay, which we created, okay. Now I'm making and adding the second rule in local file, okay, which I already explained to you. That is a reject ICMP rule, okay, and you can compare, okay, these both rules and their impact and their output, okay. And for that, again, I need to edit the local, okay, the local file, okay, the local rules files, which are available here. Yeah, these are the local rules file. This is the local rules files, okay. So I'm editing this one as well, okay. Now, so you can simply use this command to open, okay, your local and rules file, okay. Yeah, this is empty, okay, nothing is in it, okay, because we installed the fresh copy of this snort. So we need to add some new rules here, okay. So I'm using that reject ICMP rule here, okay. I'm adding that one, okay. So simply you can just type that rule here, ICMP, and I need to add the destination IP address here, okay. Specifically I'm making this rule for the target machine, okay. And then you can add the direction here, and here you can add the your machine address because the traffic is coming from 1.5 and towards to your machine. Okay, so that's why you need to add the both IP addresses here, and the port number should be any. Okay, and then you can add the message here. Okay, the message should be, you can add any message here. Okay, for example, I'm adding that reject ping from 5. Okay, reject ping from 5. Okay, I'm adding this one, and then you can add the semicolon here, and then you can add the ID. Okay, the unique ID. For example, I'm using this one. Okay, if you want to add the version, okay, this is the revision of your rule. Okay, so you can add. Okay, if you don't want to add that, so no problem at all. Yeah, it's totally up to you. Okay, so I created this new rule in the local file, in the local rules file. So let me check again. Okay, ICMP, yeah, that's correct. Any, and okay, and then the message should be reject ping from this one. Okay, yeah, and yeah, that's perfect. You can just save this file and close this file. Okay, again you can run your snot. Okay, and you can generate again the attack from other machine. Okay, and you can see, okay, now the destination port unreachable, okay, so it is rejecting, okay, the ping packets. Okay, and you can also check its impact here. Okay, reject ping from this one, this is the IP address. Okay, I'm just using the last digit of that machine address. Okay, and already that machine IP address is visible here. Okay, so, and this machine is rejecting, okay, the ping packets. Okay, so this is the power of the new rule, okay, which we created. Yeah, okay, now just I'm clearing the screen, and because now we are trying to use and install, okay, the second honeypot, okay, pent box tool. Okay, so you can simply download that tool from this website. Yeah, this is the pent box. Okay, this is available here, so you can just simply download. So this is the easy way, okay, to downloading and settle down this on your Ubuntu. Otherwise, you can also use the commands for that as well. Okay, so yeah, this is very small file. Okay, so this file is available here. Now you can see and check the download folders. Yeah, this is the pen box. This is available here, and download it. Okay, so now I'm just unzipping, okay, this file. First of all, I need to exit from this. Okay, and check. Okay, I need to enter in the home. Okay, and then yeah, okay, I need to go to the download directory, and here you can check. Yeah, this is the tool available here. Okay, this is the tool. Okay, so first of all, I will unzip this folder. Okay, perfect. Okay, so now the one program is important, okay, before installing this pent box tool. Okay, and that is a Ruby file. Okay, and we are using that command, and we are installing the Ruby programming language, okay, for that, okay, because it will provide, okay, the complete libraries, okay, to run this tool, okay, and the full term, okay, Ruby full ensure that the necessary components of Ruby developers are installed. So we are just running this command here, okay. Yeah, and so simply, okay, it will just take, I think, the 1 second, and just simply install this one, okay. Okay, then after this, okay, I'm just running, okay, this tool first, okay. So you can just go to this tool directory first, okay, and yeah, that is okay, you can enter in the directory. And before going to the next step, okay, we need to run the nmap command on the Kali Linux. Okay, nmap. Okay, you can just simply run this and then come back here. Okay, nmap is a network mapper, is an open source network scanning tool. Okay, we use that from the Kali. Okay, so now I am just running, okay, this honeypot, okay, here, pend box, okay, and for that you need to use this command. Yeah, so this tool is started now, see, pend box 1.8 version. Okay, so it contains the different options, okay, like cryptography tools, because this is the complete toolkit. Okay, it contains the network tools, web and the IP grabber, okay, geolocation IP, mass attack, okay, and the license and the contact and exit as well. So we need basically the honeypot, and which is available in network tools, okay, so that's why we need to give the option to this, okay, and then in the network tools, these all the tools are available for us, okay, and on the third number you can see we have the honeypot as well, okay, so I'm using this third one, okay, you can just simply type the number 3, okay, so then it will provide the two options to you, okay, first is the auto configuration command, and the second one is the manual configuration command, okay, which is we are using for the advanced users, okay, so I'm using the second one, okay, here you can just type the second, and here it is asking that you need to insert the port which you want to open, okay, so I'm using, okay, the telnet port here, okay, and the port number for telnet is 23 here, okay, so I'm just opening this one first, and you can just press enter. Now it is asking that you need to insert the message here, okay, which will display, okay, so for example, what will be the message, that this is the important machine, for example, okay, and this is the important machine, and do not tamper, okay, tamper, and then in the last I'm using these some symbols, and you can just simply type this message here, and then you can just press enter, okay, and it is asking that you want to save this log file with the intrusions, so you can just press yes, I want to save this, yeah, and this is the by default, okay, this file, okay, for further review and for further analysis, this file is by default available here. So this is the complete path and the address, okay, of this file, okay, which we are making now, okay, you can open this one as well, and then you can just press one time again enter, and it is asking that you want to activate the beep sound when there is an intrusion. Okay, so no need for this. Yeah, you can just simply type the no. So now the honeypot is activated, okay, on your port number 23. Okay, so simply now I'm just going to the attacker machine and I'm trying to attack on that machine. Okay, and then you can check the impact on there. First of all, I'm again running the nmap command here. Okay, and this time you can see the telnet TCP port is open. Okay, so now I'm just simply using the telnet telnet command here, and you can type the IP address of that machine here, and you can just run this command, and you can see this message will be displayed here. Important machine, do not tamper. Okay, and you can also check the impact of that attack here. Okay, that honeypot activated on port 23 and intrusion attempt detected. This is the time and this is all the details. This is the IP address, okay, and all the things are here. Okay, so this is the beauty of honeypot. It will detecting all the attacks on the real time. Okay, and you can, if you will generate again the attack from there, okay, and then you can see the impact is again coming. See, okay, yeah, so this is the one thing which we used by using the honeypot. Okay, and I'm just stopping this attack here, and yeah, that's perfect. Okay, so now the next port which I'm using, that is HTTP. Okay, so HTTP port we are using. Okay, to setting that port setting here first by using the pent box, and then we are generating and try to access this system from the Kali Linux browser. Okay, and then we will check the impact of this attack on the honeypot on the target machine. Okay, so again I'm starting the pent box tool. Okay, for that you can type again this command, or you can just use your arrow buttons to find the previous commands. Yeah, pent box, you can just run again this tool. And again we are using the honeypot. So you just need to add the second option here. And the third, on the third number the honeypot is available, so we are using the 3 here. So now the honeypot is giving the 2 options, so we are using the first option this time. And automatically by default this is the fast auto configuration, so this honeypot is activated on port 80 automatically. So this is now activated on the port 80. And now we can just go to the Kali machine, and we can open the browser, and we can try to access that network from here. Yeah, the access is denied. The access is denied, and we will check the impact on our target machine. See, intrusion is attempted and detected. And this is all the details are available here. You can again generate the attack from there. Open another browser. Again, you can try to access that. So access is denied, and you can check the impact here. See. So this is the port 80 by using the honeypot. And yeah, let me. Okay, so now in the third activity, I'm using the port 22. Okay, so for that, again, you can start the tool. Okay, and the second tool we are using, and you can go to the third one as well. Okay, and in the third tool, okay, again, I'm using the manual configuration, okay, of this port. Okay, and here I need to add the port. Okay, so I'm using the 22 port, which is unique for the SSH protocols. Okay, and you can just press enter, and here you can add any message. Okay, if you want to add any message, so you can add here that message. Okay, for example, I'm adding that okay, for example, yeah, this is the message. Okay, you can just press enter. It is asking that you want to log with intrusions. Okay, you want to save the file. Yes, so this will be the file. Okay, this will save automatically for your future reference. Okay, this is the by default directory which is available here. Okay, and then you can press one more time, and then it is asking that you want to activate the beep. No, so now the honeypot is activated. Okay, so again we are just going to that machine, and we will check the impact of this all the process. Okay, and this time I'm using the SSH command, okay, to generating the attack on this machine. And yeah, the connection closed. Okay, the connection is closed. Okay, and we will check the impact there as well. Okay, this side, yeah, intrusion attempt detected. Okay, all the details of the IP address of the attacker machine, the time and the port number, all the things are available here. Okay, and you can easily use, okay, this tool, okay, to generate the different types of attacks. Yeah, so you can also close this, and you can also stop the pinging there. Yeah, that is automatically stopped. Okay, so, and yeah, another thing, you can easily check the IP addresses, okay, by using this command. Okay, and then your IP address will be visible here. Yeah, okay, and this is your Ethernet card address, and you can also check here as well. Okay, and first of all, for example, IP address show command, you can check. Okay, and this will be your address. Okay, and this is my Ethernet card address which I used. Okay, especially in the snot side. So you can easily check these all the IP addresses, okay, by using this command. Okay, the one thing which I'm showing to you, for example, if you are not adding the new network card, okay, so they are using the same IP address in both cases. Okay, so that's why it is important you can create your own network, and you can set your own IP address there first, okay, by using these tools. And simply when you will finish these all the stuff, so you can just export, okay, this complete machine file by using the file and the export button from here. Okay, and you can select the both machines. Now these machines are running, so you need to stop these machines first. Okay, so let me stop these machines, okay, first, and then I will show you how you can make a complete image, okay, for further use and for the future use as well. Okay, so again, go to the file and you can export, and by pressing the shift button you can select the both machines from here. Okay, and then in the format settings, okay, this is the format settings, so this is recommended, okay, 1.0, this is the stable format. Okay, so you can select this one, and here you can just define, okay, where you want to save this. Like in my case, in the documents, I'm saving these all the files. Okay, but you can specify the address here, the destination here, and if you want to change your name of your image, okay, so you can change here. Okay, anything you can add here. And yeah, if you want to include ISO image files, okay, which you already used for Ubuntu and for the Kali, so you can just check this box. Okay, but if you don't want this ISO file, so you can uncheck. Okay, so but my recommendation is that you can include this for the first time. Okay, and then this is some other appliance settings. Okay, if you want to rename, okay, any machine name here, so you can just rename that. Okay, and for example, the both machines are here. If you want to do any changings, okay, in these machines, so you can do that. Okay, and when you are just clicking on the finish button, so automatically, okay, the file will be created and stored on that provided directory for future use. Okay, and you can just simply then delete if there is any problem in these systems. So you can just simply remove these all the operating systems, and you can again import, okay, that file which you created, okay, by using this import option. And from here you can select the local file system, and then you can just select that, okay, machine which you created, that file, okay, that is over file, and you can just press next, and I think it will take 5 minutes, okay, from you, and the both machines are again available to you here. Okay, so by using this strategy, you can create a complete virtual machine image for future use. Okay, and you can easily make, okay, the new setup for any new lab. Okay, or if there is any problem in the previous one, so you can use the new setup. Okay, so at the same time, if you have a good computer device, so you can also use the multiple operating systems here. Okay, like you can add the Windows here, and you can add the more operating systems here. Okay, and you can also do your all the labs in this simulation environment. Okay, so I hope this is useful. Yeah, if you want to add the new machine, for example, in this virtual machine, so you can just simply click on the new button here, and you can just set your new machine name here. For example, I am just adding the Windows, and you can just set the platform here, okay, the type and the version, where you want to save this complete file. Okay, by default this is the folder, but if you want to change the folder, so you can, and then you can just press the next button. Here you can do some changings with the hardware. Okay, so recommended CPU is the 2. Okay, and you can little bit increase the storage as well, so it's totally depend on your available storage on your computer. Then you can press the next button, and then you can press the next button and then finish. Okay, so this platform is available here for the Windows now. Okay, so simply you need to go to the settings here, and you need to do the two things. Okay, uncheck the floppy, this is the old device. Okay, we don't want this now. And another thing you can do, that is in the journal tab, you need to select, okay, the shared clipboard with bidirectional, and the drag and drop feature with the bidirectional. Okay, that's it. And then go to the storage, and here you need to select the empty CD icon, and from here you need to just pick your downloaded file. Okay, that is Windows, that is Ubuntu, that is Kali Linux. Okay, anything you need to select, and then you can just press the OK button. So automatically that ISO file will be integrated with this platform, and then you can start and just install the complete operating systems, okay, in the virtual machine. Yeah, so that's it from my side. Yeah, if you have any questions or anything you want to ask, so please. Yes.